Hi guys, in this video we are going to solve this problem exponentiation, and this is also called binary lifting. So we have to calculate a to power b and then take modulo with 10 to power 9 plus 7, and here we will be assuming that 0 to power 0 is 1. Okay, and for this b will be up to 10 to power 9, this power. Okay, so the brute force approach for this will be to multiply a up to b times, like a into like up to b times we can do. Okay, my handwriting is a bit bad. Up to b times we can do. Okay, then what, but this is going to time out because b is up to 10 to power 9. So what we can do is we will use something called binary lifting. Okay, so the idea is like a to power b we are having, so instead of multiplying like a into a, what we can try make multiplying them in a power of a. So that means like b we are going to break into binary. So like say, so I will take like b 15 to explain. So a to power 15, what we can do, we can just say like a to power 15 is equal to a to power 1 into a to power 2 into a to power 4 into a to power 8. And if you add this like 1 2 4 8, then you will get 15. Okay, so then what we can do, we can just take modulo with this. Okay, now how do we calculate these values? So for that what we can do, like a to power 1, for this a to power 1, like we can simply just use our modulo operator and we can get this answer. Okay, now for a to power 2, what we can do, we will have this answer. This answer we will multiply like twice, we will use, and this, for this we will take remainder, so this will become our a to power 2. Okay, and for a to power 3, sorry, a to power 4, again we have this a to power 2's modulo available, so we can just take a square of it and again take modulo. And similarly this we can do for other like a to power 8, a to power 16, like that we can do. Means here we will need up to a to power 8 only, because a to power 8 only is there. Okay, so a to power 8 only we can do, like same thing, square we can do and modulo we can take. Okay, now so here in this case like 1 2 4 8 all bits are set in this 15, so that is why we are multiplying all of them. But when some bits are not available in that, so we will exclude them. So I will take an example for that. So say we have a to power 13, so like we have a to power 13, so this 13 in binary we can write like this 1101, so this, so this we can write like this. Okay, so this 8 over 13 we can also write like this. So here last bit is there, so it means a to power 1. This is not there, 0 second bit, so this a to power 2 is not there. This third bit is there, so a to power 4 is there. Okay, this this fourth bit is there, this means a to power 8 is there. So if you take some of these like 1 4 8, then it will become 13 only. So like this we can do. So what we will do, we will see like if that bit is set, then we will multiply that on with our answer with this a to power 1, and if this bit is set, then we will multiply with this a to power 4, and like similarly for this bit we will multiply by a to power 8. Okay, so that is what we will do. So I will explain more in code, so let's code it. Okay, so I am having our power function here. So this power function will take 3 arguments. First it will take our number, then it will take power. So basically num is like a and p is like b there in problem. Then I will pass this third argument as mod. Okay, Then what I will do, I will store our answer in this variable answer, and I will make this as 1 initially, initialize this with 1. Then what I will do, I will just write to y, and I will take another variable a in which I will store initial this answer. Okay, so what I will do, I will do like while p. Okay, so if you remember what we were doing, so we were checking if that bit is set. So if that bit is set, so if this last bit is set, then what we are doing in answer, we are including that a's power. So answer into a we are doing. Okay, okay, and this a we are updating, we will be updating with a into a modulo mod. So this means like a for in this a, so initially this is like a to power 1. After one step it will become a to power 2. After a second step it will become a to power 4. So like this it will go on. Okay, then for this last bit, we as we have already done calculation, so what we will do, we will remove this last bit. So like this we will remove this last bit using this right shift operator. Okay, then what we will do, we will just return this answer. Okay, so then I will just take input. Okay, so a b we have to take input, and I can declare a variable called modulo, so which is equal to 1 e9 plus 7. Then what I have to do, just return this, then just take input, and I will go with my function a b and this modulo. Okay, now let's test it with the given input. Shit, sorry, but I have defined long ler. So here we are using these variables in long because this number is in like 10 to power 9 range. So if you are multiplying those, then it will be like 10 to power 18, 10 to power 9 into 10 to power 9. So this will overflow this in integer. So that is why we have to take them in long. Okay, so let's try again. Okay, so we are getting, yes, we are getting correct. Okay, so I will submit this. So I will just make a file. Rename this. And yes, this is accepted. Okay, so in next video we are going to solve this second problem, exponentiation 2. By that time, thank you guys for watching this video, and if you have any doubt, then you can ask in comment section.